I'm here with Charlie Boyle, the man that needs no introduction. DGX, it's been 10 years, and it's been quite a ride for you, I'm sure. Like, catch me up till now. Like, DGX, 10 years ago, like, Vera Rubin.
Yeah, it's fantastic. 10 years ago in this very building, about in the same place that we are right now. It may have been a few feet over that way. We introduced DGX1. It was one system. It was behind velvet ropes. And back then, everyone looked at it and said, oh, my God, what am I ever going to do with 8 GPUs? That's way too much computing power for me. That was like the number one customer question in year one. Like, can I virtualize it? Like, how am I going to use 8 GPUs? Look at where we are 10 years later. You know, thousands, tens of thousands, millions of GPUs deployed. And we just launched a brand new set of rack scale systems. The Vera Rubin platform, all of Rubin, new Vera, new storage, all in the keynote. It's been a fantastic ride for the past 10 years, and we're looking forward to the next.
This is the AI factory floor behind us. I mean, at what point did it become the AI factory?
So, interestingly enough, there's a lot of evolution because, like I said, when we started DGX1, people just bought 1 and 2. You know, and then that was 2016, 2017, 2018, people started clustering them. From the very first DGX1 that we ever sold, we included Mellanox networking, before Mellanox was part of us, as an east-west network. Well, in year 1, year 2, very few people connected those things together. But in that kind of year 2, year 3, people started doing that. And by our Ampere generation, A100, as we saw our customers grow and look at new cluster possibilities, new networks that they needed, new storage that they needed, we introduced a new product that we called DGX SuperPod, which was taking those A100s, 32 of them at the time, connecting them with InfiniBand back then, and working with partner storage so that a customer had a SuperPod product, fully delivered, you know, fully installed, turnkey to them, and with a performance guarantee from Nvidia. Now, what was the SuperPod was the basis of what we now call AI Factory. And, you know, that was really the transformation. It started in A100. By the time we got to Hopper, that became the first AI factory, and then Blackwell just took off from there.
Yeah, I heard that it's like, it is the co-working, like all the companies coming together. I mean, you know, Nvidia acquired Mellanox, of course, for the networking side of it, but storage also factors in, and connectivity and everything else. I mean, 72 GPUs here, but you need to scale more.
Yeah, and, you know, so a modern AI factory, you know, people ask, like, well, what does that look like? Well, in the Blackwell generation, our AI factory building block design, our SuperPod design, was 8 racks. You could connect that with InfiniBand or Spectrum-X. And then one of our great partner storage that you see, you know, all behind us here, if the audience could see everyone on the show floor, it's fantastic. But as part of that, with the Grace Blackwell design, it was our first liquid-cooled system. So when we talk about partners, you need a much bigger ecosystem to make your AI factory work. We've got cooling partners here. We've got mechanical electrical partners here. We've got data center partners. I did an interview with my friends at Equinix yesterday. All those people need to come together to build the modern enterprise AI factory so that customers can get really the value they want out of AI without necessarily needing to have all those disciplines, all those skills internally to physically build it.
The supply chain is more complicated than ever. All right, walk us down the factory floor here. Things are a little different.
Things are a little different. Last year was 1 rack. Now we've got 5 racks. So we're starting out right here. And this is our new Vera rack. And the reason, you know, Jensen talked about in the keynote, the need for more CPUs and AI computing. When you're thinking about agentic work, I do a lot of GPU computing, but it needs to also do a lot of thinking. If I'm asking it to build code, I need to do unit tests. Well, unit tests are just things that run on CPUs. So now in a modern AI factory, you have a recipe for every 8 Vera Rubin racks. You add 1 rack of Vera. That's 256 Veras in that rack, coupled with that NVL 570 or NVL 72 rack sitting right there. You put 8 of those together, and now I have 1 Vera for every Rubin that's in my AI factory in that pod to allow me to do that agentic work that I want to do. The CPU is working hard. It's making sure the GPU is doing everything. But of course, what is AI? AI is fed by data, and that's why we made another new announcement this year, our STX rack, and we can walk down a little bit to that thing. A little further down here, we're going to pass our LPX rack. We can talk about that a little bit.
I was going to say Grok. The Grok acquisition came together so quickly.
It did, yeah. I was actually on holiday in Australia when I saw the email about it. I'm like, oh, this is fantastic. Because when you think about Grok and you think about where Blackwell was, where Vera Rubin is and where we're going to be beyond that, they serve very different ends of the spectrum. But in a modern AI factory, as Jensen talked about token economics, you can really drive up that token economics and give your users differentiated services. And that's really where the Grok Rack is all about. It's combining with the power of the Vera Rack, the Vera Rubin Rack, and the Grok Rack for extremely low latency inference and that agentic workflow that just, value matters. Your CEO needs something really fast. Your users want something very fast that you can monetize. And then I may need infrastructure servers as well in my environment, and that's the next rack over here. This is our brand new Ethernet 256 rack, and what that is those are all our MGX servers, and they're built by our partners worldwide. Of course, it's the Nvidia booth, so I show them in gold, but every AI factory, you need a lot of infrastructure servers. I need management servers. I need data servers. I need all sorts of things that are helping my AI factory run at 100%. You look at a modern factory today, anywhere, I've got robots doing things. I've got, conveyor belts doing things. Well, there's computers controlling that, and that's what this rack does. This is infrastructure. Everything that you've run on an x86 server or a Grace server now has an easy way to slide into a unified rack to be part of your AI factory. And that brings us to our last rack here that we were talking about, storage. It's a big new, announcement because you can't have AI without data. And that's where we're going with STX here. A big part of that, you look at this and you go, is NVIDIA becoming a storage company? Absolutely not. We're helping our storage ecosystems. They're all on the show floor here. But for the agentic workflow, you need to access data a little differently. You need a different tier of storage, whether that's context memory, whether that's agentic storage. And so we, just like 10 years ago when we built DGX, we built a blueprint, we built a reference architecture. That's what that STX rack is. It's a reference architecture that every storage partner that's here and every storage partner around the world can build their software stack on their solution. They're going to take STX to market, not me.
That is a lot of E3 storage. I'm going to have to do the math later. Kioxia was showing 256 terabyte E3.
Yeah.
256 times all that, that would be an ungodly capacity.
It's a lot, but that's what you need for agentic, because when you think about it, your agent is doing work for you. But your agent, one, has to run in a safe, secure sandbox, so everything it's doing, all its code generation.
That's the Vera rack.
It's the Vera rack, but then all the data that it's building, you may ask it to do something. Your one agent running your task may generate a few terabytes of data just thinking, processing. Well, it all has to live somewhere, and that's what runs in this rack. And it's super critical that it's in the pod now because we're not dealing with human speed anymore. We're dealing with the speed of computers and agents that can create data, create massive amounts of data, destroy that all in a few seconds, way faster than you or I could ever code something. And so that's why we need this new tier of storage in the AI factory, in the pod itself. It doesn't replace traditional storage. High performance storage still need that. File storage still need that. Object store still need that. All of our partners do that. This is a new tier, a new opportunity, and everyone's supporting it because they see where the agentic workload is going. NVIDIA is doing the R&D, doing the reference architecture, so all of our storage partners that have decades of experience in storage software stacks can deliver a solution really quickly.
So this kind of a fabric, I was seeing things like, GPU is able to do a PCIe call and directly access storage. Like the CPU doesn't have to be involved. You can get, all the way through RDMA and everything else. So
yeah, and that's what's really powerful, and that's why it's in the rack now. Now, we've always done RDMA to our great storage partners when we were really focused on training. But now we're focused on inference. The workload looks different. The number of users are different. And the speed at which data gets created and destroyed is very different. Because for that agentic workflow, I'm going to do a ton of processing. It's going to do a ton of research. It's going to pull information from all over my company that I've let it do. And I'm going to use that temporally. I may use that for a minute. I may use it for an hour. Maybe I use it for a week. But it doesn't replace my system of record. Where that data is stored in my enterprise is still there. And one of the unique things and the reason that we're so excited about STX and our partners are so excited about it, when you think about agentic and you think about Claw, what did we say in the keynote? Well, we're going to give you a safe way to do Claw. Well, as part of that, what did we say? We're going to start with a denial policy. But if you're a developer, you want to build something, your company has already given you access to files. Where is that access control stored? It's often stored with the storage partner. They've got your access control list. They've got your retention list. Well, by partnering with the storage vendors and having a connector from that agentic flow, that claw flow into what your company's already approved for you, you massively increase developer productivity and decrease developer frustration with like, really, do I have to go ask IT for the 100+ permissions that they've already given me? No, start from that and only ask for what's new.
Well, it's easy to imagine a storage story inside an existing Fortune 1000 that's just not designed for the speed at which agentic AI is going to pepper the existing system with requests.
Right, and that's why we want a new tier of storage, because that system of record that's running your business, the last thing you want is millions of brand new requests coming in because it was never sized for that.
Yeah.
But that system of record is still super important. It doesn't go away, but now I need to get data from that, load it into the system here, do the agentic work, do it securely, and when that agent is creating terabytes of data for that one thing that you asked it to do, or that idea that I had to do, well, usually it would just throw that data away, but there's value in there. There may be a couple megabytes of data that like, hey, I'm going to want to rerun this agent a month from now, a year from now, so I can take that little bit of data that's the critical core of what that agent created for me and then put that back in my enterprise store with all the security, with all the rules around that. So when like 6 months later, I'm like, hey, I want to rerun that thing, I don't have to recompute it for a day or a few hours. It's like, oh, just give me that recomputes in a few seconds.
From DGX1 to this in 10 years, thinking about like the pace of innovation, 10 years ago, was anything at this level even an inkling? Like,
it's just exploded so much, even in the past couple of years. When we first came out with the SuperPod, and I had great customers around the world, they put their first implementations in, everyone did a press release when they had 32 systems. But that was state of the art. They were building large language models, frontier models for their country. That was the biggest use of SuperPod. It was largely outside of the US because all the language models were English based. And we had great customers in Korea, over in Europe, all looking at like, I need a model that is local to me, understands not only my language, but all the things that are important to me. And from that point where we started SuperPod to the Hopper generation, fantastic. I have a customer, they were represented, I just came from our 10-year user group, and they were telling me on their Hopper SuperPod that they had, they moved from Hopper just to last generation Grace Blackwell. They had a single job that they had to run for every single customer. So their growth was limited by how many new customers, how many times they could run this job. That job on their Hopper cluster took 18 to 36 hours. When they moved to the Grace Blackwell cluster, 20 minutes. That's quite
a leap.
It's 50 to 100x faster. And so that means they can get 50 to 100x more customers. They can serve their customers a lot less expensively. And they were telling me on the new math they're looking at for Vera Rubin, it's going to be another huge leap for that. So that acceleration is just crazy.
Can we even comprehend where we'll be in 10 more years?
I can't imagine. I know I'm still going to be standing in front of something beautiful and gold that our engineers around the world put together. We'll be talking about stuff that happened in the last year, but we'll probably be talking about some brand new innovation that just cracked in the last month before GTC that year too.
The thing that blows my mind with all of the AI factory is like this exact infrastructure, the same stuff. The thing that is generating the Will Smith eating spaghetti gif is the same thing that's driving the robots and the self-driving. It's the same tokens.
It's the same tokens, and that's one of the the core beliefs at Nvidia. And one of the interesting things from DGX1 to now, customers that were running and developing software on their DGX1s run on Rubin today because CUDA's been around. This is CUDA's 20th anniversary year too. CUDA's been around for 20 years. It's that commitment to compatibility up and down the stack that when we have new hardware, it just gets faster. There's a little inside thing that is really unique in the tech industry. Because of that software innovation that we do from the time that we announce a product to about a year later, software alone doubles your throughput generally. Every generation, I look at it and go, is it going to happen again this year? And every year it happens. Now, what's crazy about that is we're the only piece of technology that I know of that after you buy it, it gets more valuable. You look at your phone every year, it's like app, update. Oh, it's slower. I better buy the new one this year. Our customers from the time they buy, if they buy early, they get more value. Not only did they get in early and they're generating tokens today, but 6 months from now, a year from now, that same system generating more tokens.
Yeah, it is kind of mind blowing, the software uplift. Even just down on the smaller systems like NVFP4 when it launched versus now is a night and day difference in terms of the developer experience, performance, everything.
Yeah. And as customers move to that, I was hearing from developers at my user group meeting, and they were telling me like how much of an exponential boost they got when they went from FP8 to NVFP4, and they're like, oh my God, like I can do so much more now. But the same system supports all the precision, so almost everyone's on mixed precision now. So the stuff they can do in NVFP4, supercharged, but we're still supporting all the other things for pieces of code maybe they don't need to rewrite. But everything works together because it's one CUDA.
Is there anything else that has come together with Vera Rubin, or any stories or anything that you were hoping somebody would ask you about, or anything that has like, oh, this would be an amazing thing to talk about?
You know, I think the biggest thing in Vera Rubin, Jensen touched on it in the keynote, a little bit, but he had so much information in the keynote. We've looked at power for a lot of years because everything is power limited, like from your house to the data center. Like your house, it's like it comes with 300 amps. I just built a new house. It's like I was weird with PG&E. I'm like, I want 600 amps. Like, why? I'm like, I want it. Give it to me. But my house is power limited. A data center, the day you build it's power limited. You're probably never getting more power there. And so when we announced the Blackwell generation B200, we had some power smoothing in it. And our customer said, well, the AI workload still, it's fairly spiky. So with our Blackwell B300 platform, we put a lot more capacitance in our power shelves because there's no more power PSUs in the individual server. It's a centralized power shelf. So we put a lot more capacitance in there to smooth that out. In Vera Rubin, for the geeks out there, we're now at EDPP1, which means the system, whatever load it's at, looks like a flat line. You're not blasting the grid, you're not dropping things. And what that means is every watt of power that's in your colo environment, that's in your data center, you get to use for tokens. Today's math in a data center, about 60% of your provision power is actually useful to you. You always over provision for security, you over provision for backplate. We can now guarantee you that we will not go over the number that you set in the system. It's software settable. And that's really deep in the system. It starts at the chip. There's new circuitry in the chip, in the rack, in the power supply, so that as you set a power limit, the entire data center respects that. And it's multi-direction, as Jensen talked about. Like, you might be in a situation, I grew up in the DC area, it gets hot in the summer, air conditioning goes up, we get thunderstorms. The utility could say, hey, lightning just took out a substation. Could you dial down your data center 2% so the great people of Northern Virginia still have air conditioning? That used to be a phone call, that used to be a couple hours. Now the power company can send us a signal and the systems will readjust to the most important workloads, keep those running at 100%. Other workloads that may not be as power sensitive, turn that down. All that's automatic. And what was at the end of the keynote that's super exciting, when Jensen talked about DSX, you saw it was beautiful, and it was a lot of simulation. That simulation's being built in Northern Virginia. We're going to operate a gigawatt scale data center to prove all this technology works, to prove that it's safe to run at 100%, and to take that technology and bring it to all of our customers worldwide.
Yeah, I'm really excited about having a much more modern power grid and much more useful moving pieces in the power grid to just smooth all that out, because it was built a million years ago, and it's been great a million years ago, but we need to put that same level of effort and care and love into it once again.
Yeah, and that's why when you come to GTC today, you're not just seeing server vendors or add-in card vendors. You're seeing mechanical vendors. You're seeing Schneider. You're seeing Vertiv. I saw this great fully enclosed liquid cooling solution that looks like art. It looks like something you might see at Burning Man, but it's like a fully enclosed liquid cooled rack, and it's beautiful because that's the technology that we need to push to make efficient use to drive the cost of tokens down.
Nice. Well, you got any parting words of wisdom for our audience?
I mean,
anything to be hopeful about, look for?
The thing is, no matter where you are today, with AI, start big. I've had a number of sessions, a lot of customer presentations this week, and the days of, I want to start an AI and I want to do a chatbot, that's over. As
I've been there, done that, yeah.
But it's a lot of companies haven't. As Jensen said in the keynote, if you've got software developers and you haven't given them AI coding tools, you're behind. So number one piece of advice, if you're employing software developers and you don't have AI-driven tools, get them that tomorrow. You'll be behind. Number two, think big. Because that idea that you had, the thing that you and I thought about, and it's like, oh, that's cool, but I'm never going to be able to do that. You can probably do it now and try it. And we have a secure way for you to try it. And when it works for you, we have great tools, great people and great partners to help you scale that idea.
I've definitely noticed, we went around the Inception tour, and I've definitely noticed that the friction is like we've got a small team of subject matter experts, and they're able to better, bring what's in their brain into reality a lot easier with these tools.
So many Fortune companies that I've talked to said, I now have a small team of agent builders, and it may be 4 or 5 people for 100,000 person plus companies. And what they're super excited about is those 4 or 5 people are still going to be their core agent builders, but so many other people in their operation and engineering departments can now build their own agents. For their production agents, things that need to hit 1 million people, it'll still be those, those super experts, but now everyone in the business can do something with an agent and be productive.
I've definitely seen that in the software side as well.
Yep.
Thank you. Thank you again.
Yes, no, thank you for your time. Looking forward to seeing you next year and 10 years in the future.
Thanks.
Thanks.